Hello, hi.
No.
Hello, okay. So, welcome the CEO. So today, WAP is a product design consultancy company. So we design products for our client. So I'm going to share with you a project that we have done end to end, from design all the way to production. Okay, so I'm going to draw something. So just focus on the wall. Now, we wanted to start off with a project, okay, a product. So today there are many products in the world, from handphone to PC to maybe a fan or whatever. But then today we want to talk about the kiosk, because it's a live example that we have done for our customer. Okay, so now before I start, I just want to draw a very simple kiosk. So a kiosk, if you look at it, okay, basically, okay, as a simple structure, it is basically a screen with a stand. Yeah. So this is a kiosk. But then when we want to design a kiosk, we want to make sure that we have understanding from the customer. Okay, the customer. What do we want to understand the customer? We want to understand the requirement, and also all the current whatever problem statements. Okay, that's where we want to start off with ID. Okay, today this is a kiosk, this is what you know. But then we subsequently we understand the customer's requirement, and they share with us what they want. Then there will be a lot of add-on. This is just a simple kiosk, and then there will be, for example, they want it to be more curved. They want to have a keyboard, okay, a slide-in keyboard, okay, and then there are features that whereby you are able to change the ribbons, okay, that you're able to pull out like a drawer, and then you can replace with a ribbon, and so on and so on and so on. So this is something that the industrial engineers will start to figure out how this will look like, and then maybe they want a slant kind of a feel rather than a flat screen. So these are the consideration that the design engineers will, the industrial design designers will start to scope in. Okay, so this is one. Now subsequently, as we go into a more in-depth, then what we will do is that we will have a few sketches. So this is just a very rough sketches. Forgive me, I'm not a designer, but then this is the kind of thought that we have. We will sketch a few design. So we have a few design. Okay, which my colleague Gordon will show you as we go through. So this is the stage on the screen. Now, as we go through all this, assuming that the customer has determined that this is the design that they want. Okay, forgive me. If they want this particular design, so what will happen here is that then this will be the ID. Subsequently, you got to go back. What will happen here is that you need to break down. So forgive me, my drawings. You need to break down. So this will be the cover. This will be the LCD screen, example, and then this will be the keyboard. Okay, the keyboard tray and so on. So what I'm trying to highlight here is that this will be the kind of mechanical engineering effort that is involved. Okay, because you need to know what is the content. Having the external view is not good enough. You need to know what is the content. That's where the mechanical engineering team will come in, as demonstrated by my colleague here. So this is the next level. And of course, if you look at a product in general will consist of 5 components. Okay, let me go through. A product, any product that is powered by electrical power will basically have 5 components. Now, what are the 5 components? First thing, mechanical parts, right? The mechanical parts. What are the mechanical parts that you can think of? So I ask a question. You say metal, you say plastics. Then of course metal has many levels. You have alloy, you have aluminium, blah blah blah. But all these are classified under mechanical. Okay, so far so good. Now, the next thing is that you will never have a mechanical part, just one piece. You will have a plastic, you have a mechanical, you have a housing, you have the enclosure. Then what will all these, what is the items that integrate them? You know what's the items that will join them, integrate them? Okay, second item is screw and nuts. Screw, nuts. If you agree with me, most of the items, mechanical and mechanical, you put them together, nothing will happen. You need to have a form of screws and nuts. But of course, we understand the customer's requirement. They want minimum number of screws and nuts. So that's where the engineers, the ID and mechanical engineers will brainstorm. Can we have a clip-on concept? Whereby the more clip-on you have, the lesser screw and nuts you need. Understand? So these are two. Okay, this is what I meant. Of course, there are many other ideas of screw nuts. Maybe we use glue. Okay, this is give you a very high level kind of explanation. Now, a product like this, a kiosk, okay, is never complete without item 3. What is item 3? Very simple, electronics. Okay, electronics are we call hardware. I mean, I just put the word electronics. Now, you will definitely need to have electronics. So meaning to say, over here, maybe see whether I have red color or red color. This is ID design, that's appearance. In the contents, you will definitely have PCBA. You probably have some electromechanical items, maybe I call it a battery. Okay, so these are what I call the electronics item. Okay, inside, this is outside, but this is open up to see what are the contents. So this fall under the mechanical engineering portion. Electronics, you have PCB or even electromechanical parts, the battery or whatever, the power supply. What is needed to integrate them? What is needed to integrate all the electronic parts? Okay, correct, it's a cable, cables, connectors, right? That's where you will see, things are connected. Okay, definitely there in a device like this there will be an MCU or IPC inside. MCU, sorry, there will be a contents like this inside. So you can see now these are the 4 items: mechanical, screw and nuts. You join them together. Electronics, mounted onto the mechanical through use of screw and nuts. The raised screws, and then you have cables and connectors that fix all the electronics part, connect together. Now the last most important thing, what is the item? So what do you think? What is the item? Number 5. Number 5, you need software integration. Without a software, putting all this together, nothing will happen. Okay, so the last one is software. Okay, a very high level. This is what I meant in terms of the components that make up the entire product. So this is the product that we are going to highlight. In fact, over here you can see we have a kiosk just in front of us. Okay, so I just want to go through the process with all of you. Now, once we have all this, what is important in terms of supply chain? Now, that is customer, right? That is customer. This thing here is what I call the supply. The supply, as in the suppliers that make all these parts for us. So it can be, for example, okay, all these items. Then what is needed here is that we have a BOM. Once you have a BOM, you may have a mechanical A, mechanical B, okay, and then you may have a PCB A, C, and then you may have a power supply, D. So this is what I call the supply chain management. By having this, it's just drawing. It's just drawing, right? It's just office on the PC. But then you need to go, after this is done, you need to go one level down. Identify the supplier. Okay, supplier has many. Of course, I'm just putting a very high level on the component. This is under the BOM structure. The BOM, this is the BOM. Of course, you will have the screws, M5, M4 screws, whatever hexagon, whatever those kind of shapes. You will have that. Now, looking at this, okay, yeah, important thing, BB cables. Software is not inside because software basically is just software. There's no need. Now, once you have this, you start to identify the partners. Okay, now what do you want to establish here? You want to establish, then you will be able to go back to what I call a very simple, very important steps as a prototype. You need to put all these, integrate them together so that you can work out the POC. Okay, so like that. So the cycle is like that. For the customer, ID, and then determine the supply chain. You work with all the suppliers on their capability, 6axis, 4axis, or whatever tonnage, this and that, the type of materials, all selection will be within here and here. Subsequently, you bring all this to the factory, to the design center. You put all this together. You assemble them together, POC, and later on, what will happen here is that you will add on your software. So now this whole thing will then form the entire prototyping or POC. Okay? So this stage is to prove that all this works and make sure that this one still ties back to the customer requirement. Okay? So this is what we meant on prototypes. So we have one prototype here. Later we can go a bit more in depth. My colleague here will also show you the steps. As I explained on the wall, we also go through from the PowerPoint slides. Okay, so far? Now, once this is determined, many times it's not possible to do it right the first time. Not possible. But we always want to achieve that level. Through what? Gordon, can you tell me? We want to minimize the number of prototypes. Okay, the correction of iteration of prototypes at this stage. What is the stage that we call? Do we know? What do we want to do in order to reach this target with very minimum iteration as much as possible? This process is very, very important. Let me use another color. Okay, there's an orange color. Now, at this stage, one of the processes very key, which I call it as simulation. Okay, in this process, as we draw out the entire BOM, okay, it is very important for us to do some level of simulation. Okay, that simulation will tell us whether this one, for example, that kiosk that we are doing, right? Whether this drawer, if I open close, or hard handling, ping pong, will it last? So this simulation will help us to swim down whether the design can cater for that kind of aspect. So this is what I call simulation. Today we use SolidWorks, which is very commonly used in the market. SolidWorks, okay? So far clear? So we need to do as much as possible on this. Then we determine all this and then we bring in the materials. Now, again, as I said, no design is perfect at first try. No, not possible. So there is a need for some kind of evaluation with the customers. Go back to this is what we call the iteration. So there will be iteration, maybe one or two iteration. Okay, iteration. So that we fine tune this and that, okay, to cater for the final products that we want to deliver to the customer. Okay, eventually when the customers test it, we have the user experience, we have user interface, all this will be considered during the design stage, and then we will be able to deliver the right products to the customer. Now, other than simulation, we also do FMEA to determine what kind of failure mode engineering analysis. If you do A, what is the potential problems? If you do B, design B, what are the potential problems? So during the design stage, all these will be considered so that we filter as much problem as possible to ensure a 99% prototype the first time. Of course, the 1% you cannot avoid. You want to fine tune this and that. That's why you have iteration, and then you probably reorder another modification to make it a perfect product, and then you deliver to the customer. Now, sometimes, because we mentioned the key thing today that I want to share, I use another color. Today I want to share here is not just on the design. We talk about the entire discussion is we want to do design to build. Okay, now remember this is just 1 minute. So when everything is confirmed, what we will do is that we will need, for example, the customers I wanted, hey, why not you do 100 pieces or every month 200 pieces and so on. Yes, we are able to do because we have already have a firm design, a proven POC, and a ready supply chain. Of course, during the supply chain, the suppliers for mechanical A may not be producing 100, maybe they just do 1 or 2. At that point of time, they may use just maybe 3D print or even soft tool. But eventually, if you want to have that volume, the production volume of 100, 200, it all depends on the volume. Then you will need to start to invest on what we call as tools, machining tools. Okay, and definitely there's a cost, machining tools, so that you are able to punch, okay, to that quantity and so on. It all depends on volume, so that the quality of the tools also depend on how is the volume. Okay, so eventually when we have all this, we will now order based on a number, an MOQ, okay, so that we are able to proceed to the next stage. Okay, next stage, which is production. This is I. Okay, production. So remember, this is design to build as in production. So subsequently, when we have the production, that's where we build out the whole thing. Okay, and we also work with the customers very closely. Production is not just making about the part, right? How do you manage the packaging? Okay, assuming the product is made in Singapore but delivered to Japan, for example. So you need to consider packaging. And today, WAP, we also do the packaging for our customers, and not just on packaging. In fact, we also do branding. Okay, right? It's always the first part, first appealing branding to capture the customer's attention. Now, once we have this, of course, what we do is that we have quite a number of logistic partners. We work with them, and then we deliver, okay, to our customers. So you will then go to our customer as in a finished good. Okay? So that's all what I mentioned about the entire journey of design to build. Now, one thing I have not mentioned here is that from the supplier, all these parts, okay, they may come from a second tier supplier. Okay, a second tier supplier. A second tier supplier will get their parts from where? From the earth. Okay? From the earth. That's where you dig all those materials, metal, and so on and so on. So you can see it's end to end. Now the customer is still not the final. Who is the final? Who is the final? The final is you and me. Okay, I actually draw a smiling face. Which is the end user. Okay, for this case, the kiosk and the end user is our customer, which is in the government sector. They are the final one, end user. The reason why I say end user is that customer, it can be we are building for a distributor, and then distributor will then sell over to their end user. So you can see the end to end is always from the earth all the way through all this process to the end user. Okay, so I'm done with my presentation. Now as we go through all this process, my colleague will actually demo and show you in a more detail, because this is a graphical process. So as I write, I think you will comprehend better, and that's where we can interface, we can interact more. Okay, thank you.